are lattices, then their direct product is again a lattice, and it is a partial ordered set. And here partial order is defined like this: x1 x2 xn less than equal to y1 y2 yn. If and only if when x1 is less than y1, x2 is less than y2, x3 is less than y3, xn is less than yn. Correct? And it forms a lattice with respect to this order. And join and meet are defined like this. Correct? x1 x2 xn meet y1 y2 yn. It is in each slot we will take the meet of corresponding. In a similar way, in each slot we will take a join of corresponding. Correct? So this forms a lattice. Is a lattice called as a direct product of lattices. Of lattices L1, L2, Ln. Correct? Now, fact is that A1, A2, An covers B1, B2, Bn in L is equal to L1 cross L2 cross the direct product of lattices if and only if when AI covers Bi for some I in set 1 to n and Aj is not is equal to Bj for every j not equal to I. Correct? And I left this fact as an home assignment for all of you to prove, isn't it? All of you have to prove this fact. Correct? Now, proposition 1.8.7. Proposition 1.8.7. The direct product of semi-modular lattice is a semi-modular. The direct product of semi-modular lattice the direct product of semi-modular lattices L1, L2 dots on Ln is semi-modular. You have to prove the direct product is semi-modular, correct? For this proof, take any x comma y belongs to L such that x covers x meet y and y covers x meet y. So take any x comma y belongs to L such that x covers x meet y and y covers x meet y. So what is our claim? What is our claim? Our claim is that x join y covers x as well as y. This we have to prove, correct? Let x meet y is z1, z2 or so on zn. Then x will be what? x1, x2. In between I am just writing also one thing. Okay, leave it. x1, x2, xn, where xi covers zi for some I belonging to 1, 2 up to n, and xk is not is equal to zk for every k not is equal to I, isn't it? It means try to understand what it is. Z is this, x meet y is this, then what could be x? Don't write, just I am writing here to explain, isn't it? Also you can write on your copy, but it is sufficient, isn't it? Now it's explanation. It is what is x basically? z1, z2, correct? And in ith place, isn't it? Here zi minus 1, here it will come xi like this, and here it will come zi plus 1, and here it is zn. Means except at this place, at all places, isn't it? It will be same. Xk is equal to zk for every k not is equal to I, isn't it? At this place, here at ith place it is zi, here it is zi, like this, zi, this is the ith place. So at ith place it is xi, and where xi covers zi, correct? And we know what this is the meaning of cover, and at the remaining slots they are same. Xk is equal to zk for every k not equal to, correct? So similarly, y will be y1, y2 dot so on yn, where yj, because it is not necessary that I and j coincide. So we will discuss both cases, when I and j are equal and when I and j are not equal. So let's say j, when yj covers zj for some j belonging to 1, 2 up to n, and yk is equal to zk for every k not is equal to j. It is like that, correct? It means that it is what? It is z1, z2, zj minus 1, and here at the jth place it is yj, zj plus 1, z, it is like that, correct? Now we will discuss two cases when I is equal to j and when I is not equal to j. Both things are possible, isn't it? So in both cases we will prove that x join y covers x as well as x join y covers y. So case 1, when I is not is equal to j, correct? This is the case. If I is not is equal to j, then what will be x join y? X join y will be, we say that like this, it is t1, t2 dots on tn, where ti is equal to xi and tj is equal to xj, yj. tj is equal to yj, and tk is equal to zk, where k not is equal to I comma j. Means when k is not equal to I comma j, then tk is equal to zk, correct? It means what basically? It means that it will be like this. It will be z1, z2, and at the ith place it will be like this basically. x1 xi join zi, and at jth place next one will be what? Zi plus 1, and at jth place, if jth place come forward, then it will be what? X yj j zj, zj plus 1, and this is zn, like this. And of course, what is xi join zi? Definitely it will be what? Xi. So this will be equal to xi and this will be equal to yj. So just I am writing in order to explain you, this term will be equal to what and this term will be equal to what. This will be xi and this will be yj. We need not to write like these things, just it is okay. t1, t2, tn, where ti is equal to xi, ti is equal to xi, and tj is equal to yj, and tk is equal to zk, and k not equal to I comma j. So it is clearly seen that here it is obvious that x join y covers x as well as y. X covers y, correct? In the next case, if you see, case 2, when I is equal to j. If I is equal to j, then you see what is x join y. It will be what? u1, u2 dots on un, where ui is xi join yi, correct? x join yi, ui is equal to xi join yi, and uk is equal to zk when k not is equal to I, correct? It means that at ith bits what will happen, z1, z2, zi minus 1, and at this place it will come xi join yi, and here zi plus 1 zn basically. And it is obvious that we can see that x join y will cover x as well as y, because x join yi will cover xi as well as yi, correct? So as you know that as Li is semi-modular, we make use of semi-modular lattices here. As Li is semi-modular, so xi join yi covers xi, correct? And xi join yi covers yi. That is ui covers xi and ui covers yi. So when ui covers xi yi, it means what? Hence x join y covers x and x join y covers y, isn't it? So it implies that L is semi-modular lattice, correct? So in this way we have proved that L is a semi-modular lattice. Xi join yi covers xi, xi join yi covers yi. Because you see that by the definition that here xi join yi covers xi and xi join yi covers yi. Is it clear? So definitely x join y covers x, x join covers y. Here in the previous case what happened, that xi joins zi is xi, isn't it? And we know well that xi covers zi, we have taken in the, and yi covers yi. So in both cases we have seen that L forms a semi-modular lattice, isn't it? So in this way this proof ends. So now there is left one example as well as few definitions. We will continue the same.